Hello students, how are you?
Fine, thank you.
Welcome to this mathematics class today. Again, you can see what is the topic we'll be looking at today. What is it?
Union of sets.
Yes, and I know in our last lesson we touched on union, but today we're going to go a bit more in detail and we're going to focus most of our attention on union. Is that clear?
Yes, sir.
Good. So it therefore means by the end of today's lesson, you will be able to answer any question on union of sets. And in our lesson, we will also be touching on representing these sets, the union of these sets on Venn diagram. So it therefore means before we go any further, we must know what we mean by union. When we say union, what do we mean? Who's going to answer?
The complete thing.
Okay, Harish, yes. What
the
is
complete thing from in the order.
The complete thing in the order. When it's complete, you close. What means a complete?
Join together.
Join together of what?
The elements.
Elements from where?
The sets.
The sets, right? Whether it be 2 or 3 or 4. But when we join together all the elements. So for example, in your school, you may have grade 7, 8. But even within grade 8, you're part of the grade 8. Within grade 8, what you will find is that you have, for example, you have A, B, C, and D.
Yes.
So A is one subset, B is another, C is a third, and D is the fourth. But then if you put all of them together, well then we can just say that we have the union of all the classes in grade 8. Alright, when you take all these students and you put them together. Is that clear?
Yes.
Good. So union refers to putting all the elements together. The elements from the various sets, we put them together and we call that new set which is created, we call that new set the union of those subsets. If you look at our first example, consider these two sets. Look at them carefully. We have the set A, a set of letters. We have 7 letters there. And the set B, set of some other types of letters. We have total of 8 letters in the set B. What we will do is try to answer some questions on these two sets. And the first one we will want to answer a question is about the union of these two sets. If you take these two sets and you put them together in one bigger set, what will the elements of that bigger set be? I see Danica is ready to answer. But do not answer as yet. Because first I want you to remind me, someone else can remind me, of if we're going to write, remember, we have to list the elements in the union of A and B. So how do we write A union B? How do we write it?
A, U, B.
We will write, for A union B, we write A, the symbol for union, B, equal to, and for the set of, we use the curly brackets. And then we start throwing in all of the elements inside. Alright? It's as when you cook in cook up, you take everything and you throw it inside of the pot, right? Or oh my, but you people don't cook them. Any of you cook?
Yes, sir.
Okay. Good, so you just take everything and you throw it in. So that's what we're going to do with these two now. We're going to take everything here and just throw it inside of this set. So I will do it, right? Because you guys already know how to do this. So I will do it and then you will tell me whether I'm right or wrong. Okay. Is that fair?
Yes, sir.
Good, so let me do this. I will just throw everything in. And I have A, B, C, D, F, H, K. Good, I've emptied the one set. Now I come to the other one. Then I have B, C, E. Tell me if I'm wrong at any point, you know.
Wrong.
G. And you're just waiting to hear me say, tell me if I'm wrong.
Yes, sir.
No. That's not nice for you to tell me I'm wrong. If I really thought I knew what I was doing, all of you shout out you're wrong. Where did I went wrong? Where did I go wrong?
From D, sir.
From F, somebody saying from D.
D. From D.
From D.
Yes.
I wonder if I can take your advice, because it seems as if you are divided among
D, sir.
yourself too.
No, sir, from D.
From D. Here?
Yes, sir.
So what about from here? So I should take out what is following?
Yes, sir.
Alright, I'm taking, yeah, you guys are the mathematicians here. So take out what is following there, and what should I write?
E.
E in this set. So it doesn't matter which set we pull from.
No, sir.
Okay, so, oh, someone is saying in order, so we go in order. Alright, so we take E, followed by?
F.
Uh-huh.
G.
Mm-hmm.
H.
Mhm.
I. J. K.
So am I correct now?
Yes, sir.
Okay, at least if I had a book, I know maybe I would get a star in my book. Alright, good. So this is how we will list the set A union B. Having listed set A union B, the next task will be for you is to represent this set on a Venn diagram. But we will quickly revise certain things about the Venn diagram. We will quickly revise about the Venn diagram. So let us consider our Venn diagram. I'm just drawing any Venn diagram here. It doesn't necessarily mean a Venn diagram for these two. Alright? I will just draw a particular Venn diagram. And if this is the universal set, and we have subsets, what is this shaded region showing?
A and B. Union.
All of A and all of B, and in mathematics we write this as A union B. So if we have two sets like this, we would say that this is what it represents, A union B. Now, this diagram A union B can be written in, or can be represented in three parts. Let us just look at what the three parts will be. And this is a universal set. We have a cross here. We have the second part there and the third part there. Or we can say the regions. Let us focus on this region here, the union. So this first region here is A only. So if we're going to list the union, well then we can say that A union B is made up of A only, the elements of A only. Alright? What else can we say? A only plus what?
A intersection
B only.
Alright, so someone is saying we can say B only. And we can also have to add in there
intersection
A intersection B. You said A intersection B. So, given this diagram here, if we want to give the elements of the union, well then there's the elements in A only, or we count the number of elements in A only, number of elements in B only, and then the number of elements in the intersection. Now, it doesn't mean that you have to do this, because for example, someone might have A only, followed by the intersection, followed by B only. That is okay, as long as we add those three together. Is that clear?
Yes, sir.
Alright, so our task now is to represent these two subsets of some universal set. We're going to ignore the elements outside of these two. We're going to pretend as if there are no elements outside of these two in the universal set. But our task is to show this on a Venn diagram. So, we need to know, or we need to be able to find those parts if we're going to show it on the Venn diagram. So we start off by finding, one important part is the intersection, A intersection B.
B.
What are the elements that are in A and also in B? The elements in A that are also in B. Yes, Claudius. Let Claudius answer this question. Yes, Claudius. The elements that are in A that are also in B.
I would say
I said C.
C is in both of them. All right. He's saying C.
K. H.
K is in both of them. H. Is he correct so far?
Yes, sir.
Any other, Claudius?
No, sir. Yes. Yes, sir.
All right. Vasha, you also had up your hand. Can you help Claudius?
B.
Vasha is saying
B.
B. Vasha is saying B is also in common. Anyone see another letter that is in common there?
No.
H. Is H in? We already have H identified. So we can list them in alphabetical order to be B, C, H, K. Yes, it's important that we have our intersection first. Because now that we have the intersection, we can then find what is this region, A only. How do we find what is A only? If we know what is the intersection, we know what is A.
So
How do we, yes, Harish?
you take out the intersection.
Take out the intersection from A, and what is left will be called A only. So we say A only will be equal to, and I will ask Liana to tell me what are the elements that are in, that will be left back in A if we take out these elements here. The elements which will be left back in A if we take out these elements. Yes, Liana, list them for me. If we take out these elements that are on the line, what will we have left back there? Alright, I will start. A. We don't want B. We don't want C.
D.
Then we have D.
F.
F, correct. What about H?
No.
No, because H is in the section. What about K?
No, sir.
So then we stop there. Alright?
Yes.
Good. We need to find what is B only. B only. And alright, let me get a volunteer this time. Yes, Junior. Junior will tell us what are those elements in B after we take out the intersection. Yes, Junior, what will we be left back with in B?
E,
E,
G,
E, what you said? G,
I,
I, correct?
J.
J. Any other, Junior?
No, sir.
Is it correct, class?
Yes, sir.
Alright, so we close off this. So now that we have the intersection, we have A only and we have B only, it should make the drawing the Venn diagram a very simple task for us. Alright? So we're going to now go and draw our Venn diagram. So we see that there is an intersection. So because there is an intersection, we have to join the loops. A, B, we join the loops because there is an intersection. Then we list the elements in the intersection. And the elements in the intersection are?
B, C, H, K.
Good. Then we list in A only. The elements in A only are?
A, D, F.
And the elements in B only are?
E, G, I, J.
And we finish with the Venn diagram. So it's just a matter of a couple of seconds we have to take now to complete our Venn diagram. So it is important for us to do this. If we do this, well then, sketching the Venn diagram becomes easy task for us. Is that clear?
Yes, sir.
Do you have any questions?
No.
Alright, well, you will copy this quickly and you can stare at it. Maybe something that you see that you might want to ask a question about. So take note of this. In the meantime, while you copy the diagram, I'm going to put example 2 on the board. Are we ready for this next question?
Yes, sir.
Great. List what list the set X union Y. X union Y. What are the elements in X union Y? 1 to
12.
12. Alright, I am listing what you're telling me to write 1 to 12. So I write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But you told me to list 1 to 12.
Except 9.
Except 9.
Except 9.
And 11.
So then it's not 1 to 12.
Yes.
Okay. You see, I was being very obedient, you know. And I was listening what you told me. So it's 1 to 8. That would be 1. We have the 2. We have the 3. And we can go on listing all of them. 4, 5, 6, 7, 8. Then we have 10 and 12. So we have X union Y. What about X union Z?
Sir.
Someone is saying something wrong here?
Sir, finish, sir.
X union Z. You take everything in X and you merge it together with everything in Z. What will these elements be?
2,
3,
4,
6,
9,
8, 9, 12, 15,
10,
12,
15, 16.
Alright. Let me check, double check this and see. You say 2, 3, 4, 6, yeah? 8, 9, 10, 12, 15, 16. Perfect. So we can list union, because that's what we learned earlier in the lesson, how we can list the union of sets. Alright, what about Y union Z? Y union Z. Y union Z will be equal to the set of,
1 to
we're
6.
taking Y and Z, 1 to,
1 to 10 and then 12, 15, 16.
yeah, be careful you say 1 to 16, huh? So we know we're going straight from 1 to 9. Alright, let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9.
12, 16.
What about 10?
No, sir.
Why not 10?
That's God, 10 and 10.
10 is not in either Y nor Z. Good, so we have Y union Z there. I'm afraid to give you this next one, you know. Alright, let me give you. Look at this next one. X union Y. Yeah, union Z. Do you think this one should be easy?
Yes, sir.
X union Y union Z. And what are the elements?
Sir,
1
to 10.
No.
1
1
to
to
10,
10.
because it's everything we're looking for. We put in everything in this one set. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
12, 15, 16.
12, 15, 16. So we have X union Y union Z as given as this here. Now remember that in listing union of sets, we can only list a particular element once. How many times can we list an element?
Once.
Good. We cannot list it twice. So that's why, even though, for example, 6 is appearing in all 3 sets, we cannot list 6, 6, 6 there. We only have to list it once. Any questions? All right. Let us look at what the Venn diagram of X union Y union Z of 3 intersecting sets. We're going to look at a Venn diagram of 3 intersecting sets. what it will look like. If we're tasked with shading X union Y union Z, where do you suggest we shade? Yes, Zephaniah?
Sir.
Okay, Tanis is answering. What are you saying, Tanis? I can't hear you, man. Speak loud. What you saying? Between the closed loops. So, should I shade X? Not everything in X. Should I shade Y? Are you sure? Remember, we're looking for the union. What does union mean again, class? Everything you put together. So if you want X union Y union Z, it means you want everything in X, everything in Y, everything in Z. Alright? So if we're going to shade, we shade everything inside of these here. Good? So we shade everything in X, union Y, union Z. We shade everything here. Good. So this is what the shaded region for the intersection of three subsets will look like. So you know what is our task now? Our task is to,
Put that on a Venn diagram.
yes, take these three sets here and represent them on a Venn diagram. Do you think you can do that?
Yes, sir.
Alright, how do you suggest we go about doing that?
Sir. No, sir.
Start off by drawing our Venn diagram?
No, sir.
That's the hard way out, man. There's an easy way out.
Make sure there's an intersection.
Yes, we find all the intersections. Correct. Once we find all the intersections, well, then the problem becomes easy for us to draw the Venn diagram. So we start off by finding them, and we can do this as quickly as possible. Let me see how fast you can help me to do this. For example, we start off with X intersect Y. What will this be equal to?
2, 4, 6, 8.
2, 4, 6, 8. X intersect Y?
2, 4, 6, 2.
2, 4, 6, 8. Remember, X intersect Y refer to the elements that are in X and in Y. You see 2, 4, 6, and 8. Alright, two of them. Good. So then we can go to X intersect Z. X intersect Z. What will this give us? In X and in Z.
6,
Is 2 common?
6,
Or you telling me it is? 6 and
12.
12. Good. Now what about Y intersect Z? What will this be equal to?
3, 6. 3 and 6.
Sure we stop there?
Yes, sir.
There is one more intersection. What about this intersection? X intersection Y intersection Z. Now we're looking for those elements that can be found in all three sets.
6.
6? Is 6 alone?
Yes, sir.
Yes, sir.
Zafira?
Yes, sir.
6 alone? Everybody else agree?
Yes, sir.
Good, 6 alone. There's no other element but 6 in all three of them. So X intersect Y intersect Z is equal to 6. And of course, we can now go on to, for example, find what is X only. We can find what is Y only. We can find what is Z only. But I think we can jump straight into our Venn diagram. Okay? So sketch your rectangle. Put in your three intersecting loops. And then you can start labeling your intersection. Which of the intersections? Alright, important question. Which of the intersections you think we should start with?
X and Y.
X and Y this here?
Yes, sir.
Not quite.
X intersects Y intersects Z.
Very good. We shall start with X intersect Y intersect Z. Yes, Kanisha is saying x intersect y intersect z. We start with that main intersection, and then we work our way out. So if this is x, this is y, and this is z, our universal set, we start by labeling. What is in the middle of all of them? What can be found here? So we label 6. So we finish with that. Now let us just go up in reverse now. Then we go to y intersect z. Remember we finish with this one here now, right? I will just draw a loop along them when we finish with them. Y intersect z. Y intersect z. This is set y, this is set z. So y intersect z will be this region here. Do you agree?
Yes, sir.
And what are the elements that we must put in that region? 3 and 6. But 6 is already there. So we need to add in the 3. So do I put a 3 here?
No, sir.
Here?
Yes, sir.
Correct. Good, so we finish with this one here. You see how fast we will complete this diagram now. Then we come up here. X intersects Z. Are there any elements in X intersects Z?
Yes.
6 and 12, but we already have 6 there. So just a 12. And the region that we will put it in is here, right?
No, sir.
Here?
Yes.
Correct. So we have the 12 there, because see what is reflecting here, X and Z, we have 12 and 6, and here we have 12 and 6. We finish with this one here. Come to the next one. X intersect Y. 2, 4, 6, 8. But we already have 6. So we have to list 2, 4, 8. So we come here and we list 2, 4, 8. Please ensure you list them in such a way that someone looking at this, you wouldn't list them, for example, like this, 2, 4, 8. Because if I look at that diagram, I might think that this is 248. So make sure when you're going to list numbers like this, you kind of jumble them up, you know? So nobody wouldn't think it's one single number. What else we have to list there? X only. Yes, baby is correct. Baby is saying X only, Y only, and Z only. Alright, let's start with Z. We're working our way up now with Z. Now we need to look at Z here, this loop, to see what are the elements we already have on the diagram. Do we already have 3?
Yes, sir.
6?
Yes, sir.
9?
No, sir.
So we have to list 9. What about 12?
Yes, sir.
15?
No,
So we
sir.
list 15. 16?
No,
So we list 16. And we finish with this set here now. Okay?
Yes, sir.
Then we come to Y. We list 1 already?
No, sir.
So we put it in. 2?
Yes, sir.
So we don't put it in. So we finish with these two. 3?
Yes, sir.
Yes, 3 is there. 4?
Yes,
4 is
sir.
there. 5?
No,
So we
sir.
add in 5. 6?
Yes, sir.
7?
No,
So we
sir.
add in 7. 8?
Yes, sir.
So we finish with this here. And we left with one more thing and we finish with our Venn diagram. Alright, so you see this, listing these will make it very easy for us. Then we go to the last one, X at X. We have 2,
Yes,
4,
Yes,
6,
Yes,
8,
Yes, sir.
10.
No, sir.
So we have 10 here, 12,
Yes, sir.
and we finish, problem solved. Venn diagram complete. Okay? Good, give yourself a clap for that. Venn diagram complete. Very good, students. Alright, so anytime you have Venn diagrams to do, don't ever let it be too much troublesome for you. Remember, the key is identify all your intersections. As long as you identify all your intersections, you list your intersections on the Venn diagram, or you label your intersection in the Venn diagrams first. Having labeled the intersections in the Venn diagram, you start with the main intersection. If there is a main one, then you continue with the others. Any questions?
No, sir.
You sure?
Yes, sir.
All right. Well, I have a question for you. What have you learned in this lesson? We looked at union of sets, and we looked at how because we can summarize now, We know that how we can use some sets and find the union, list it out. And we also know that how we can represent the union of some sets on a Venn diagram. To make it easy for us, we list all the intersections and we label them onto the diagram. And then we can label what is X only, Y only, Z only. If we had a universal set and we were considering elements out in the universal set that are not in X, Y, nor in Z, where will those elements be listed?
Outside.
Yes, outside here. Those elements would have been listed outside there. Good? So, we stop there for this lesson on union of sets, and I really look forward. I enjoy working with you, and I look forward to continuing teaching you mathematics, and I myself will learn even as you learn. Bye for now.
Bye.